and students to the Science Exhibition 2026.
We are delighted to have you with us today.
Our opening ceremony will begin very shortly, so I kindly request everyone here to take your seats.
To begin today's ceremony, please rise for the singing of our national anthem, Nagaraku. Thank you. Please be seated.
Science inspires us to think, explore, and innovate. It is now my pleasure to invite the organizing chairperson, Ms. Divya Bharati, to deliver the welcome address. Please give her a warm round of applause.
A very good morning to everyone. Our guest of honor, YB Teresa Kok, our distinguished panel of judges, respected teachers, parents, and dear students, welcome to the Able Learners of Science Exhibition. It's my pleasure as the chairperson of this year's Science Exhibition Committee to welcome all of you. Today, you will have the opportunity to explore 35 exciting science exhibits created by our students. Each project reflects their hard work, creativity, and their curiosity. I encourage everyone to visit our booths and please ask them some questions and support our young scientists. Science is not about just reading or learning from textbooks. It's about exploring, discovering, and solving real-world problems. So through these exhibitions, I believe our students will be developing valuable skills such as critical thinking, communication, and collaboration that will benefit them in their future. So I would like to express my sincere gratitude to our panel of judges for your time and encouragement, to YB Teresa Kok for honoring us with your presence, and to our dedicated teachers and supportive parents for guiding and encouraging our students every step of the way. So finally, congratulations to all our students for your wonderful efforts. I wish everyone an enjoyable and inspiring science exhibition. Thank you.
Thank you, Ms. Divya, for your inspiring speech and warm welcome.
It is now our honor to invite our respected principal to deliver the opening address. Ladies and gentlemen, please welcome her with a warm round of applause.
Good morning, all of you. How are you, my students, doing today? Good. you are the special people for today. And with that, a warm welcome to the dedicated YB Teresa Kok, who has always supported us. In fact, this is the 8th exhibition of able learners, and she has come 4 times. Isn't that great? Because wherever we are, the people of the community, they belong to the group that supports the community here, and she has always been very supporting member of the community. So thank you, YB, and the team who is with you today. Welcome all of you. The judges, thank you so much for taking your time to want to look at the exhibits and rating. But rating here is not just your exhibits. Rating here is to see how you stand there and explain the exhibits to all of us. So that matters, that counts. With that, I want to tell you, able learners' main purpose is not just academics alone. It is survival. It is life skills. For example, look at your principal wearing a colorful sari. You like it? Yeah, this is called the science sari. It involves colors, mixture of colors. So we are all made up of calculations and science, and that is why we give a great importance to science exhibitions. Not forgetting the team that worked together with the IC Miss Divya, the Science Exhibition Committee. Thank you very much for your hard work. Wonderful. Thank you so much to all the teachers who have put it together for us, the admin team as well. I appreciate all your work so that we can shine our children here. Thank you, and a great warm welcome to all of you.
Thank you, Principal, for your inspiring message and continuous encouragement towards science education and innovation.
Ladies and gentlemen, it is our great privilege to invite our guest of honor, YB Puan Teresa Kok Su Sim, to deliver the officiating speech and declare the Able Learners Science Exhibition 2026 open. Please welcome her with a big round of applause.
Thanks to our MC, Ms. Punita, Principal Able Learners, Mr. Gregory, Creative Director, Mr. Siddhartha, Promotion and Marketing Director, and Ms. Divya, who in charge of the Science Exhibition year 2026, the Science Exhibition Organizing Committee members, and Mr. Krishnan, Executive Director, Applied Scholastic, esteemed judges, and all our fellow students of able learners. Good morning. Good morning. Yeah, it's really my great pleasure to come here. So this is the Able Learners Science Exhibition 2026. It's really good to come to a more spacious environment here, so that we can have we can mingle around, and because I used to come to this hall actually for different activities. So it's a pleasure for me to come here again. This year's theme is Science Shapes the World. As we enter into the age of artificial intelligence and rapidly advancing technology, it is more important than ever to encourage our children to think scientifically, ask questions, and solve problems creatively. I understand that there are 34 groups, right, participating in the science exhibition. Congratulations to every student. I think each project reflects curiosity, teamwork, and perseverance. I am especially impressed that Able Learners introduces science from a very young age through its Junior Scientist program for pre-Year 1 children and its Young Scientist program for Year 1 and Year 2. These programs will help children to develop an interest in science, strengthen logical thinking, understand the mechanics of science through hands-on learning, and unlock their imagination and creativity. I understand that this is the eighth, the eighth science exhibition organized by able learners over the past 15 years. Here, I would like to just share, especially with the parents. A few days ago, I'm the Vice Chairperson of Public Accounts Committee in the Parliament. So we used to conduct proceedings over and hold the government agencies and ministries when the Auditor General's report published anything that related to the way they spend money and issues. We'll call the agencies to us. So there was in the Public Accounts in the Auditor's General report, there was a finding over the research grant of universities and also ministry like MOSTI. MOSTI is a ministry that for science and research and R&D. So I told the KSU, the Secretary General of the ministry, and also some of the the Vice Chancellor of the universities who come. So I say, for the last few years, I've been watching all these video clips in our WhatsApp. Our Malaysian scientists, our Malaysian medical doctor, they won awards in China, won awards in UK, and one of them is a lady recently, I saw in the clip, won a medal in the Oscar of Science in UK. I think some of you might have watched that video clip, right? And that lady was formerly a researcher and medical researcher in University Hospital or University of Malaya. So they won. And I saw 2 years ago there was one Malaysian Palm Oil Board, former researcher, also won a medal in UK Scientist of the Year. Wow. We are not short of talents in Malaysia. We are not short of scientists in Malaysia. But do we honor them? So I told this, the KSU and those vice chancellors, I said to be researchers can be very lonely. You may be staying in your lab for years and nobody asks what are you doing, and nobody care about, even you come up with some invention, right? So I say it's time for us, if we want to promote talent, if we want to promote, the STEM, they talk so much about the science and technology education. So we need to like promote and honor all these researchers and scientists. I say if UK can have what? Oscar of Science, can't we Malaysia have something like this? I never seen it, our local, the government or universities organize anything like this. I say, last year, the MOSTI, the minister has given some of our MPs 10,000 ringgit to ask us to organize one, event, science exhibition in our constituency, and 10,000 for the school to organize the thing. So I give the money to a Taman Yao, SMK Taman Yao, and they really organized one, involving all the whole school and a good exhibition, and after that submitted a report to MOSTI. So I say this kind of things, right? The government should do. We should encourage, at the state level, at the secondary school level, we should start having our science exhibition, and we should promote among the children. There will be some talented one come up with something very, special, scientific, and innovative. We should promote them at the secondary school level, university level, and then we should honor our researchers. We have many researchers from different universities, and under MOSTI, under Malaysian Palm Oil Board, under Malaysia Rubber Board, under the Malaysia Timber Board. You just name it, we are not short of that. You know, recently what happened? Recently what happened was, I believe some of you, especially the parents, you know about the LCS. You know the ship, right? It was the combat ship that's supposed to patrol around our sea, what do you call that? Southeast Asian Sea, surrounding the country. The project has been long delay, right? Then after that they catch up. You know what happened? Now the ship is ready without missile. Because Norway refused to sell Malaysia the missile. If you read that, if you follow the news, you will find out. So our government really jumped to the ceiling. Then Norway we never expected this, European country can dishonor agreement contract. Because they say that due to don't know what agreement they signed with United States. So in the agreement, they didn't get the green light of GPS. You know, it's GPS, our, ways, GPS. So they cannot allow Malaysia to have the missile. So we have debated in parliament, we bang Norway, but what's the use? Then now, recently, the defense minister said, Malaysia wants to invent our own, weapons, such as missiles, such as some of some of the weapons we purchase from Russia, from France, and all that. We want to have our research. We want to come up with our own one because after being slapped left, right. So what does this tell us? Science is so important. Science and technology is so important. The country is being bullied because we don't have experts in this field. So you can have the whatever combat ship ready, no weapons, no weapons, no missile. So and we, as a country, we cannot do anything but accept, going to international court to try to get back justice. It's too late. But anyway, come back to this subject. We want to come up with scientists that produce advanced technology to defend the country or whatever. You have to start from, like what Able Learners is doing. You have to start from small, start from young. Create the interest among the children about science. Then only they get encouragement. Every year they have to present something. They have to explain, to visitors like us about what they are doing, what they are learning. Then they internalize it. Then only you can expect, if more schools, more colleges, even especially secondary schools start doing it, then only we are hopeful that in future we can have, more scientists being produced and invent and create things that are, bringing good for the nation. So anyway, thank you for inviting me to here again, to meet up with all the students and all the teachers again. So each time I return, I see more confidence, more creativity, and more young people who are excited about science. This gives me great hope. Congratulations to the principal, Punita, teachers, parents, and students for making this exhibition possible. I wish everyone a successful and inspiring science exhibition. Have a good day. Thank you.
Thank you, YB Puan Teresa Suslin, for your inspiring speech and for officially launching the Able Learners Science Exhibition 2026. I would like to invite our principal on stage to present the token of appreciation to YB. I kindly request our Honorable YB and Ms. Punita to stay on stage to view the opening performance.
So you can see the preparation here. We are going to do the opening in a scientific way. So that is why YB is away. I'm going to handle fire. Safely done, experimented. So that's going to be our grand opening, okay?
opening ceremony, right? So I officially declare Able Learners Science Exhibition 2026 officially open.
Students, eyes on me. Did you enjoy the gimmick? Did you see the fire? Amazing. That is science. All right. So, students, look to your left outside the window. What do you see? Very good. Ladies and gentlemen, we would now like to take a moment to express our sincere appreciation to the honorable firefighters who have joined us today. We are truly grateful for their time and effort in coming to our school to deliver an informative speech and demonstration. Their sharing will give our students valuable knowledge about fire safety, emergency preparedness, and the important work carried out by our firefighters. As a token of our appreciation, may we invite the honorable firefighters to come forward to receive a small token of appreciation from us. Let us give them a warm round of applause as they come forward. Dijemput bomba-bomba untuk datang menerima hadiah dan token sagu hati. We invite the principal to carry out and give the token of appreciation to the firefighters.
We kindly request all parents and students to proceed to the car park to visit the fire engine exhibition. Students, remember to follow in your group line and follow all the instructions given by the teachers. Have fun!
Save laju kan. Save. Good morning, everybody. Okay. I am from Fire Rescue Station. So with us today we have my fellow. We have Fire Officer Irene at the back. Irene, can I say hi to Irene? Okay, sorry. At the back, can you hear my voice? Yeah. Okay, so we have our team for today. Our team for Crew A from Fire Station Bukit Jalil. We have Senior Fire Officer Rosmami bin Ismail. So, are you guys there? Are you doing good today? So, let's start with, okay, do you know, this is our fire truck, okay? So, before we start, how fire happen, okay? Before we know how to put out the fire, we have to know how to, what causes the fire, okay? 3 elements. Okay, we have heat, okay, we have oxygen, and we have our fire load. Fire load. These 3 things, okay, got oxygen, got heat, got fire load, then fire happen. Okay, when you see a fire, what you do? Call the firefighter. If the fire is big, if the fire is small, then you use a fire extinguisher. Okay, where is the fire extinguisher here? Yeah. Okay. As you can see here, this is our fire extinguisher. Alat pemadam api. Okay. This fire extinguisher is used to put out only a small amount of fire. Okay, only a small fire, not a big fire. If the fire is big, Then you call firefighter. Okay? You don't use this fire extinguisher to put out a small fire. Okay? So, as you can see, this is a 9 liter or a 9 kg or fire extinguisher. So how to use this fire extinguisher? Before we use the fire extinguisher, we have to know. We need to know is our fire extinguisher is in a good condition or not. How to know? First, okay, this what we call this? This is nozzle. Okay, this is nozzle. Make sure di sebelah dalam, okay, inside there is no trash. Okay, okay, jangan ada sampah. Okay, untuk parent jangan sekali-kali ada sampah di dalam nozzle ini. Sebab apa? Di sekolah selalu saya jumpa ada sampah di dalam nozzle ini. Okay, then after that, make sure the gas is always pointing on the drip. Okay, okay, it shows that this fire station is in a good condition. Okay, then after that, never, ever, okay, put the fire extinguisher on the floor like this. Okay, you have to what? Okay. Okay. Then after that, when you see the fire, okay, there's a three method how to carry a fire extinguisher. Okay. The first, you can carry it like this. Okay. Or you can carry it like this. Okay. Okay. Or you also can drag it like this. Okay. If you put the fire, there's a method how to use this fire extinguisher, which is we call it fast. P-A-S-S. Okay. What is the first B? What is method to use the fire extinguisher? Fast. Okay. P-A-S-S. Can you repeat after me? P-A-S-S. Okay. What is the first B? Pull. What are we going to pull? This speed. Okay. This speed. We have to pull this speed. Okay. After we pull this speed, you squeeze and pull. Speed. Can you see? Then after that, second one, A. What is A? M. M what?
In the fire.
And the fire. M is the best of fire. If the fire is this high, where should you aim? Is this up or down? Down. Yes, down. Okay. Don't aim up. Then after that, S. What is S? Shoot. Squeeze. Where should we squeeze? Okay, you want me to squeeze? Okay. Yes or no? Are you ready? Okay, then after that, the last S, what is? Sweep. We sweep left and right. Okay, good. Now you know how to use this fire extinguisher. Okay, what is our emergency number? Other than 999, you can use. There's an application. If you open your phone, you can download say 999. Okay, in that application also you can call firefighter. As you can see in front of you, this is our Scania, our fire truck. Okay, it carries 3,600 liters of water inside. Okay. Oh, yes, of course it's carrying water. Okay, so as you can see, there's 7 lockers here now inside our fire truck, with each locker have on purpose. Okay, what type of emergency are we going to use? Okay, for example, this one, you know what is this? firefighter must have ceremony. Must rock. Why? Because all the tools inside this fire truck. Yes. Okay, for example, this fire hose. In wet condition, in dry condition. In dry condition, in wet condition, this fire hose weighs 50 kg. Dry condition, only dry condition. But in wet condition, it's up to 35 kg. Okay? Usually, our firefighter will carry 4 hoses on our shoulder, which is one firefighter can carry a person 100 kg. Okay? Want me to show you? No. Okay. So as you can see, our firefighter here, I will show you. This is our fire hose. In a dry condition, it weighs 50 kg. Okay. But in dry condition, it's in wet condition. Sorry, in wet condition, it's up to 25 kg. Okay. So it is very heavy. Okay, for our firefighter to carry things inside this fire truck. For example, there's one video I want to show you. Ignition tool. So this locker usually used for firefighting. Okay, we use our hose to fight fire. Okay, then as you can see, this is our rope for high rescue. Okay, high rescue equipment. Okay, as you can see, yeah. This is our communication tool, which is used when there is an accident, okay, road traffic accident. Okay, we use this to cut or spread the car for us to get inside. Okay, then so this is what it looks inside our cabin. Okay. At the back, we call it cabin crew. In front is a pilot. Okay, there will be incident commanders sit in front and our pilot. Okay, and at the back is us, a cabin crew. Okay, not cabin crew on the airplane. This one. Okay. As you can see, this fire truck carries a lot of heavy loads. Okay, that's why our firefighter need to be fit, need to be strong. Okay. So, right? Okay. Who wants to see our nozzle? Nozzle, okay, nozzle. Nozzle. Teacher also want to see. Nozzle. Get ready. Only 60 seconds to get ready. By the time the fire truck reach the gate of the fire station, we only have 10 minutes to reach the location. Okay, so as you guys know, we live in KL. Okay, traffic everywhere. Same, right? Okay, so it is important for you to be patient. Okay. So, anything, question? Right? We do have helicopter. exhibition. Okay. Women Malaysia, we do have a helicopter. We have a base in Subang. Okay. Pangkalan Udara Jabatan Wewenang Malaysia. Okay. So, any other question? Very good. Okay, any other question? Then our boss we have to deliver the 60-second KPI. That's our KPI. 60 second. Okay. Kena keluar daripada balai dalam masa 60 saat. No matter what we do in that time. Even the worst part on the 60 second is when I'm in the toilet. Can you imagine? I'm doing my thing, like the toilet today. Suddenly there's an emergency call. I have to forget what I do that time. Okay, I have to go to our again. It depends on any other questions? That's why we are here today. How to use a fire extinguisher. Okay. So, for your question just now, our rules or including this fire extinguisher is always good. Okay. Next. Any other? Okay, secondary. Any questions? Any questions?
Does everyone go there? Secondary have some questions.
Done. Okay. Miss I, done. Ask them to be. Mr. Navi. Miss I.
Alright, students, eyes on me. Let's give a warm round of applause for our Okay, students, look here. Now, we are going to proceed to enter the hall, year group by year group, and you will be going straight to your booth to prepare for your judging and presentation time. Do you understand? We will start by 3 and 1. Secondary students, please be patient. Thank you so much for being under the sun. Hello. It's 3 and 1. Year 1, year 2, I was
gambar. Boleh? Tu, bukan abang perempuan tu ada. Abang handsome.
Thank you.
Ya, Cik. Terima kasih, Pak.
Okay.
Thank you. Terima kasih.
Shaving foam.
Shake well. Wow.
But I know I wouldn't have shaved today.
After that, we add drops of colored water in on the foam. Don't press too much. Okay. Now what happens after this? Squeeze it. Wow, I see the color going down.
I'm making cake of it.
Wow, that's lovely. Look at the color spreading down.
Wow.
I wouldn't want to shake your hands now.
Yeah, and then this uncle is wearing white. His shirt will become colorful. Yes, color.
First, we need a jar with water. Then we add shaving foam on top of the water.
So your explanation is here, right? When clouds become full of water, water droplets fall down as rain. That's water droplets, right? Yes, wonderful children.
Drop.
Yeah, a lot of clouds. The cloud is too thick. We need more water. How you will end? Hold hands. Thank you for listening.
We are sending the umbrella for you, right? Hold on.
Okay.
Good job.
But we are baking soda. Not too much. Go in.
Slowly.
Yeah.
I can help you, come. I can help you. You can also do this, right? See? Right? Has it gone in? Yes. Okay. What is that? Food color. Okay.
I used that to make candy.
Yes.
Coloring.
Wow. So much.
No, what is this?
Okay, which level are you studying? Are you year 1, year 2, year 3?
Year 2.
Ah.
And year 1.
Year 2 and year 1. Yes.
They move from this level and go to that side.
Oh.
Here they're just learning. They are not competing.
Yeah. And Xavier and Dominic. Xavier?
Okay, dear, go ahead.
Okay, Xavier, can I bring the spade to the center? This is which vinegar? Which is vinegar? Vinegar. Okay, add.
See, look at my children. Yeah. Great. Who's the teacher in charge here? Come, there. She's the teacher in charge here. Good job.
What's the name of this volcano?
No, they're asking what's the name of this volcano?
My hair.
Later, I'll come back. Okay?
Look, my
Very
hair.
good job. Wow. Okay, your visitors are here. Organizing programs.
See a fun experiment called Walking Water Rainbow. For this experiment, we need clear cup, water, food color, paper towel. We fill some 3 cups and leave the in 2 cups empty. Shafak. Next.
You can help her, okay? You can help her.
I cannot hear you.
Color will come out.
Yeah, so you must show how it is a walking water rainbow. How did you get like this?
Okay. Then I fold the paper and place one
Like rainbow, right? It's your turn, is it? Yeah, explain to Ravi.
with color water.
Loudly.
With color water and the other and into cup.
Okay, that's okay. We see rainbow here.
Good.
Okay, okay, good job, children.
Slowly travel the paper towel into the empty cup. Choose the empty cup.
What's the black? Something now that's
Okay, ask YB to take this with the magnet. Cannot. Can the magnet pick up?
no.
Can?
Cannot.
Try YB. Cannot. Oh, cannot.
You cannot.
Why cannot?
Because something is plastic. Because there's plastic. Only metal objects can stick to that. Yeah. There are more.
So let's say at home you have lost your, let's say, a screw. You want to look for your screw. Can you use the magnet to look for the screw?
Yes. Like small things.
Here. Oh, good job. So cannot. Okay. Oh, because it's too many.
How? Something is hiding here.
Something is hidden here, she said. Is it something? Something is hidden here.
There's a wand.
Good job. Magnet. Magnet.
It can attract this one too.
Okay, children, very good job. Good. So your learning is good, huh? Metals can, magnet can attract. Plastic cannot. Pencil cannot. Good
Can I
job.
have my earrings back?
Oh, 5 years old. Okay.
Hi, my name is Tamil Acha. I'm 6 years old.
Oh, 6 years.
Hi, my name is Afif and I'm 6 years old.
Oh, 6 years old.
Hi, my name is Avinya. I am 8 years old. Okay, we are going to show you how the type of materials affect whether how objects are sink in the water. Now let's have marble, water can, leaf, rock. Which object would you like us to test first? Which object would you like us to test first?
This one.
What do you think? Will it sink or float?
I think this one will float.
I'm pressing a golden star on the float column.
She's going to give you a star. Oh, that's a star for her. Okay.
Now let's test leaf floats on the water. Look, the leaf floats on the water. Your answer is correct. I am pressing a golden star in the golden star.
So if my answer is incorrect, I will not get a star.
No, it's wrong. If you're wrong, you'll put a red star.
Okay, ask this uncle.
You want it to float or sink? If you want it to sink, I will get into the bowl. Huh? I pick one, eh? Okay. I think this will float, eh? Right, eh? Huh? I think it'll float. Huh? Put it on the leaf. No star for me. Red star.
I am placing a red star in the result column.
In the result column, we get a red star. That means a red star.
Oh, I gotta hide my face. I got it wrong, eh?
Good job, children. Good job. Good
Good morning, everyone. Good morning. We are Absorption Explorers. Hi, my name is Radish. I am 5 years old.
5 years old.
5. Today we are going to show you which material absorb water and do not. We have plastic sheets, tissue paper, sponge, aluminum foil, cotton bud.
Okay.
Everyone, which material is first?
Which material will?
Should we test?
Huh?
Should we test first?
I want this.
It's not absorb water, actually. What do you think? Will it absorb water or not?
Yeah, absorb water.
It's not absorb water. Hey, I'm not. I'm using a golden sword. Do not absorb water.
No, you have to prove to me that it doesn't absorb water. Right? You show me.
Oh, show.
Now
Sheena, wait. She's saying this will absorb water.
but you are saying it won't absorb. So you must show her why it won't absorb. Put it there and show her.
Now I saw 3 drops of water.
Okay.
What this? 2, 3. Look, the water is going good.
Not going. Okay, I want to try this one.
This one absorb water actually.
You must tell how old are you?
5 years old.
5 years old. Okay, show me. How come?
Now I got 3 drops of water. Look! Look, the water's going on!
Now look, I want to look at your finger. Ah, oh, good, that's the magic.
Great, good, well done. Good boy.
The sponge absorb water. So,
What is the magic?
keep the bottom top of the pencil, then keep the balloon and rub it for 5 seconds in your head.
Oh, okay.
Water the pencil will move and you spin. Can we show now? And this is our magic solution. Magic solution is we take a cotton button. First we take a cream, then we pour milk, we take a food color and pour, then we take a cotton button and food, we don't count. But if we dip in the dishwash, then we do, we'll count.
Okay, show us.
Look.
Wow! Look at the colors.
Woo!
Wow!
Wow. And see, the blue color came.
Wow, blue color.
Blue color, look at that.
Looks like my sari color.
Woo!
Yes, isn't it, huh?
Wow!
Easy.
How's the trick electricity?
Very easy.
That is the other one, right?
Look at that.
Balloon, blue cloth. This is the other one. Okay, which one?
Group 1, show your next experiment with balloon.
Magic balloon is we take balloon, we take a water bottle, we take a pencil, and we rub on the face.
Rub on the head.
Ah, static.
What if it's both our head like me? Can rub us still.
No, we can rub on the
Oh, okay.
Okay, rub. Okay, then?
Then we will spin. Oops.
Change the balloon.
Change the
Blame
balloon.
it on the
Not
balloon.
enough static.
George, can you see golden?
Okay, rub her there.
You can see golden.
Rub
Look
her
at
there.
that golden. Look at that golden. Yeah.
Still cannot. Not enough energy yet. Change the balloon.
Last balloons.
Okay, last balloon. Okay, ask the uncle to help. See, you must have pressure. Yeah, now
Okay.
quick.
You move up.
Yeah, can move. That means you need more pressure. Okay?
Thanks for the drink, yeah?
Can you say thank you to the uncle? Thank you.
Thank you for listening, everybody.
Okay, thank you.
Ah, right. I see.
If the particles have smaller particles, they retain the most amount of water.
Okay.
Before we begin, let me ask you a question. Why do some plants need more water than others? Have you ever wondered why some plants have to be watered every day
Yeah.
while others can survive longer without them? This makes us wonder whether the type of soil affects how much water is being retained.
Do you know which type of soil retains the most amount of water?
Which things? This one?
Clay soil.
Great, you received. Clay soil retains the most amount of water. The aim of this experiment is to determine which type of soil retains the most amount of water.
Okay.
The manipulated variables are the types of soil such as clay soil, sand soil, and garden soil. And how we can respond to those variables is by checking the amount of water that has been retained. And how we can control those variables is by checking the size of the container, the amount of soil used, the volume of water poured, and the time allowed for drainage.
The materials we use are sand soil, garden soil, clay soil, 3 funnels, 3 measuring cylinders, 2 plastic bottles, a yellow board, ribbons and pictures.
Oh, okay.
We prepared 3 setup. Setup A, sand soil. Setup B, garden soil. Setup C, clay soil. We place equal amount of soil into separate funnels and pour the same amount of water into each soil sample.
The procedure is step 1. We place 500 grams of each type of soil into separate cups. Step 2. 100 milliliters of water is poured into each separate soil sample. Step 3. The time we allow the water to drain completely. Step 4. We check the amount that has been retained. We check the amount that has been drained. Step 5. We calculate the amount that has been retained.
So in the end, tell me the conclusion. Which soil?
In conclusion, clay soil retain the most amount of water because of the tiny particles that are closely packed together. Garden soil retain the moderate amount of water because of its
Organic nutrients. They're packed with organic nutrients for plants and vegetables, fruit. Like you see, like vegetable, we have tomato, carrots, all they were organic soil. And this one, garden soil.
And it's a mixture of different types of soils.
Oh.
Like sand soil is used for cactus because cactus have roots.
Long roots.
Long roots.
Long roots.
Yeah. And drains water very quickly, like as you can see.
Okay, good.
Thank you.
Thank you. Do you want to scan the QR code to vote us?
QR code. How to scan? Let's go to the Facebook. Alamak. The Facebook.
Oh yeah, you can Facebook. We have our Able Learners account and please like it.
Okay.
You're fine.
Check the email lah.
Thank you, sir. Yes.
Thank you.
Okay, so today I'll be talking about we are the Green Guardians. My name is how effective it is in reducing environmental pollution. Okay. Now, what is green technology? Green technology uses innovative methods and devices to reduce environmental impact. Okay. Now, based on our problem statement, based on the research and data that we have collected, climate change, resource consumption, and pollution are increasing due to fossil fuel demands and insufficient technology. This makes our problem statement. Now, based on the data we have collected, we now know that if green technologies were to be implemented in our cities and industries today, there would be a great reduction, a significant reduction in pollution, climate change, and resource depletion. Now, I'll be passing on to Anika to explain about the model in depth.
Now, I'm Anika. I'll be explaining about the before and after models of green technology. This model represents for green technologies for introduced. As you can see, there's a lot of pollution, there's air pollution, land pollution, water pollution. But since green technologies were implemented, it was from this. This has made our environment much better and much sustainable to live with. Now I'll be passing it on to our final green technology. I'll be talking about the ocean cleanup interceptor model. Now what is the ocean cleanup interceptor model? So the ocean cleanup interceptor model is a replica that actually works. So what is this? It's basically a solar-powered machine that helps to clean rivers and plastics from it to prevent it from reaching the ocean. So how does it work? So the ocean cleanup is basically a large floating barrier which has a convenient belt built onto this part on our model. This actually helps to guide the plastics onto the 6 storage units that are in the interceptor or the cleanup. Now, what actually happens once the plastic is reached? Basically, the workers that are in charge of this will segregate plastic from other waste. By segregating plastic from this, they will decide whether it's recyclable or non-recyclable. Recyclable plastics are cleaned and made into new products, where non-recyclable plastics are disposed with proper ethics and care. Would you like to see our demonstration for the model?
Yes. Wow. So it actually works. Wow. Collects the trash.
The workers will come in and segregate it, and plastic that is recyclable will change into new products that can be reused, such as biodegradable plastics and other products.
So it's a smaller version of the actual ocean cleanup vessel.
Oh, wow. Now,
Awesome.
we now talk about the environmental impact.
Thank you, Bhavya, for the wonderful explanation. So now, I'm going to be talking about the environmental impacts we aim to reduce and how our green technology aims to reduce it. So you see here the old model, right? So there's a lot of pollution and a lot of water and air pollution, right? So what are we trying to reduce in this? So we have climate change and carbon emissions. As you can see, the smoke coming out, these are all the carbon emissions that are coming out of our factories. So we can reduce climate change by reducing amount of carbon emissions and greenhouse gas emissions, which will reduce global warming. Global warming is happening globally, right? So we can reduce it by using this kind of technology. Next, we can also reduce air and water pollution. So you can see all the water is polluted, right? We can improve the quality of air by reducing carbon emissions from factories. We can reduce the amount of emissions we do in factories by moving on to green technology. Water pollution can be reduced by using our ocean clean ocean interceptor that Jenny showed. And also we can reduce resource depletion. What's resource depletion? So we have our population is growing day by day, right? So we need to produce more energy for that. So more energy means we have to use more resources like coal for producing energy, right? So if we conserve and use more renewable energy, we can reduce carbon emissions like I showed earlier, which improves our environment. So now, how does this technology improve? So we have wind turbines, solar panels, and also the ozone interceptor. Wind turbines, as you know, it uses wind energy, electricity. So this reduces the amount of energy we need from factories. So it improves air quality and reduces air pollution. And then solar panels. Solar panels use energy from sunlight. So this also significantly reduces the amount of energy we have to use from here. This is also a source of renewable energy. And lastly, as I told the ocean clean interceptor. So what happens is it collects all the waste from the polluted water. And as you can see here, if we keep a ocean clean interceptor here, we collect all the waste, and before it enters the ocean, it would save a lot of marine life because all this waste will be polluted from going to the ocean, and it saves many aquatic life. So I'll be passing it on.
So I'll be presenting one of the most important aspects of presentation, which is the statistics. As you can see, we have connected data in producer and line chart. The data goes from 1970 right up to 2024. This is the graph for carbon dioxide emissions. We have three countries here: Sweden, Denmark, and Switzerland. First of all, Sweden had a 67% reduction in carbon dioxide emissions. Denmark had a 67% reduction in carbon dioxide emissions, and Switzerland has had a 23% decrease in carbon dioxide emissions. As you can see, all of them have a steady decrease, and they still continue to do so today. And now I'll be talking about the Ocean Cleanup Interceptor. It has collected roughly about 3 million kilograms of trash from the rivers. Not only that, it is 100% solar powered, so there are no use for fossil fuels and no carbon emissions. And it can collect up to 50-meter cube of trash before it needs to be cleaned. Now I'll be passing on to Chan to present the opinions we have received from experts in this field.
Thank you, Kashigan, for the breakdown. Now, for the past month, my team and I have sent messages to multiple large organizations regarding the effectiveness of green technology. And fortunately, we have received a reply. That company being 4Ocean. Now, who is 4Ocean? 4Ocean is a company that works to remove plastic waste from the ocean, and this helps us to keep our seas clean on a large scale. And we have the experts here with the response.
So these are actual large organizations that work to protect the marine life. So we reached out to them and they gave their opinions and feedbacks on what they think. They think what we're doing is super good. Okay, so we're getting not only feedbacks from internal sources but also external sources. Yeah. Okay, so now for the conclusion. So we asked the question: are green technology effective in reducing environmental impact? And our answer is
yes.
Okay, green technologies are a very effective solution in reducing pollution. Thank you. Yay.
And please vote
Please
for
vote
us,
for us.
because
Vote
we are
for us.
showing the evidence of green technology that we can make a better world with just this.
Yes.
And reduce climate change and global warming. Okay.
Our team name is Green Guardians.
Next one.
Yeah, let's talk.
Yeah.
Thank you. And please, others, please vote for us also.
Please vote for us also.
We are called
We
the
are-
Astro Green Guardians.
We are Green Guardians.
We are called as Smith, right?
Okay, now we are running off. Who wants to
Thank you.
Thank you for
Thank you for
voting for
voting for us.
us. Thank you for voting for us.
You can come to my Is it okay? In here, right? We tell her, we drop her.
Miss Teresa, it's just a very short one. I just want to ask you about your experience coming here, and you've been coming here for so many years, right? How is it that every time you come, what are the differences you see? And all that? Just a very short interview.
Well, I must say that I'm very impressed with the creativity, and also the children have been coached to communicate, to introduce their invention or their findings. I think it's a very good opportunity for the children to express themselves, to internalize things that they learn in the classes. I enjoy listening to the children, and also I'm quite impressed. Like just now I went to the more elderly students, the way they talk about the green technology and all that. I think that through this science exhibition, the students will be able to internalize what they learn in the class, and they are able to express themselves, communicate well to the audience or to the visitors. Okay, good job.
had a budget. The first mole actually grow on leaf. This experiment reminds us that microorganisms are everywhere, even though we cannot see them. Dirty surfaces can transfer more microorganisms to food, causing it to spoil fast. This experiment connects to our science education theme. Science shapes our world. Science shapes our world, help us understand microorganisms and improve food safety. In conclusion, day 4 breakthroughs first a tiny mole. On day 5, we can see the mole more clearly. On day 10, we can see the microorganism almost big as our fingers, as you can see. Do you have any questions for us?
Hello. Babi ya.
About solar oven harnessing the power of the sun. It talks about using, talks about energy to bring movement. There is a condition to eat food every day for 5 days, and then we compare the amount of liquid in each group. I did my experiment using oranges. I first placed some oranges in a clean tray under the sun for 5 minutes. These dried oranges, they remove moisture and has no sign of heating, which is good because you don't want moldy food, right? And these are the control oranges, the normal oranges. They have the fungus. Yes. And these are very moldy. You also have another extraction. You did this one already? Yeah, check this one. Because this is all the rest guys? Yeah. No, that's no. It's the best secondary option because it also removes 99% of germs. If your hands are not visibly dirty or soiled. Now we go to fun facts and science facts. Fun facts and science facts. The fun facts. Hand sanitizer secret. It can clean your phone's paper. It is permanent marks and unbreakable.
Yeah.
There's only
the project that's actually engineering.
Yeah, based on engineering.
Are you gonna be in it? Really? And you guess? Oh wow.
More in business.
Okay. This one's just like the 40 minutes together. Yeah. And this one is more complex. You have to just make each one 3 times. This side, that side. And we made another pieces.
Yes, sir.
Yeah, something like that. Examples of like different plants and different
As I told you right just now, every plant has the different so here like we have different pH level like 5.5 to 6.5, like slightly acidic soil, and it helps the roots to absorb nutrients more efficiently. And here is the rice, which is 6 to 7, like slightly acidic, but it's like almost clean to the root. And like
in case like the soil is very acidic, how do you like make it less acidic?
we use alkaline to rise the pH level.
Could you like do some kind of fertilizer?
No, not fertilizer is other. We use like it gets like
have renewable and non-renewable. This produce energy.
Greetings to everyone. Okay, so let me introduce myself. I'm from year 11, and these are my teammates, Kiri, Veda, Atil, Emmanuel, and Adhavan. Today we'll be presenting you the types of renewable source of energy. So the demand for clean air is increasing day by day as the world is moving away from the use of fossil fuel. However, it is a challenge because each renewable source of energy here have their own benefits and drawbacks. Our objective today is to identify which renewable source of energy is the most sustainable source of energy. And according to our hypothesis here, hydroelectricity is the most sustainable source of energy. My fellow teammate Adhavan and I will be talking about hydroelectricity system to you. So what is hydroelectricity? Hydroelectricity is a renewable source of energy where electricity is generated through the continuous flow of water. As you can see, it is a continuous flow of water. The force of the flowing water causes this turbine to rotate, where kinetic energy is formed. This kinetic energy is converted into mechanical energy and is converted into electrical energy. So speaking of turbines here, Adhavan, do you mind explaining the types of turbines that used in a real hydroelectricity system?
So there are 3 types of turbines involved in the real model of hydroelectricity. But this is a smaller scale, so this one turbine will represent those 3. So first we have the Francis turbine, which requires a medium to high level of water pressure. Number 2, we have the Kaplan turbine, which can be adjusted. So the water flow can be adjusted. So how the turbine spins is dependent on that. Then we have the Pelton turbine, which requires medium to high level of pressure and a consistent flow of water. So the Pelton turbine can be placed near mountain regions because the pressure of water is greater and the water flow is consistent. So if you look here, this is our turbine and our water there represents our generator. So what the generator does is, when the water hits the turbine, it causes the turbine to spin and kinetic energy is created. This kinetic energy is generated into electrical energy with the help of the motor, allowing the bulbs to light up. that's all from me. I'll pass it on to Emmanuel to speak about wind energy.
Good morning. My name is Emmanuel, as my teammate has introduced me, and I'm going to talk about this wind turbine. So, this wind turbine actually uses the kinetic energy of moving air and converts it into electrical energy. This happens when the wind blows against these blades here, which will make it spin and then rotate a generator. And that's how it supplies electricity to buildings like houses. Now, since there isn't any natural wind indoors, we're using this model here to simulate what a wind turbine would actually look like in real life. And now my friend Afir here is going to give you a more in-depth explanation.
Greetings, I'm Ati, and I'm going to explain about wind turbine. So as you can see, wind turbine can only generate electricity through wind. When there is no sufficient wind available, it won't spin, it won't generate electricity. However, as you can see, hydropower and wind energy. Wind energy is less reliable than hydropower. Thank you. I'll be passing my point to you.
I am Audrey, and I'll be talking about solar panels. Right over here. So solar panels use photovoltaic cells to convert sunlight directly into electricity. When sunlight strikes solar cells, electrical energy is produced and immediately used for supply to the power. And now I'll be using my point to the production.
Hi, my name is Rita, and as the name says, solar energy, what it means is that energy is sunlight. Now, here you can see a small scale solar panel. It's made of photovoltaic cells, and here it contains semiconductor. It is usually made of silicon. And what does the semiconductor do? The semiconductor partially conducts heat or electricity. Now, in this case, it's conducting sunlight. Now, I'll show you the demonstration of this, how this solar power powers the LED light inside this house. So, we are using this floodlight as source of light and sunlight. And from here, you can see the LED light is blinking. So you can see now it's powering up the LED light. Now what this shows is that this whole process is known as this whole process is known as photovoltaic effect. What happens here is this sunlight, it excites a negative particle known as electrons. Now, when this electron is very excited, what happens next is that it starts moving around, causing the production of electricity. Now, this electricity is then sent to all the houses and everything that needs power. Now, our conclusion based on our researches and data is that the consistent renewable energy source is definitely hydroelectricity. Why? It's because, as you can see, there's consistent flow of water. When there is consistent flow of water, there is consistent supply of electricity. However, for wind and solar energy, as much as they reduce carbon emissions and it reduces the usage of fossil fuels, it depends on weather. So, lesser wind, then lesser electricity, lesser sunlight, then lesser electricity. That's all from our team. Thank you.
Thank you.
And you can vote for us by scanning this link right here.
But only one presenter? Or?
So she'll be representing overall and
Everything.
there's multiple presenters, so you have to pass.
Yeah, pass the okay.
Introduction present.
Maybe we can go here. That's are you all ready?
Present.
Hello, honorable judges. My name is Maxine. Your name is
My name is Yathin.
My name is Dylan.
My name is
And our group name is Solar Overdrive. Our problem statement is describing solar energy efficient for water irrigation. And our hypothesis is the solar panel can power drip irrigation. Our project is a solar power water irrigation system. It uses energy from the sunlight, making it environmentally friendly and also reducing the use of electricity. The purpose of our project is to ensure that with solar power energy, we can make farming easier, we can also save costs, save energy, and support the sustainability in the agriculture. My friend Dylan will explain further. Dylan, just go Dylan. So, I'll be explaining the design process. Now, setting this up really wasn't easy at all. Yeah, so basically, we started with used as the base, which we then covered in artificial layers. We then added a little water so the water can flow. After that, we added artificial plants, and then we added a tank with a DC pumps connected inside. So the solar panels are connected to the DC pump. So when light is shined on the solar panels, water will flow through and it reaches the roots directly. So why do we choose the solar power drip irrigation system when we have the traditional drip irrigation system? The traditional drip irrigation system is like the plants in the middle and then in between the plants is a pool of water. Why do we use that and why are we increasing this new method? So there's many advantages to it. First is solar energy, it's renewable energy, meaning we can never run out of solar energy, especially in our country Malaysia, we'll never run out of it. And even if there is a rainy season or anything, there will be some sunlight in the morning at least. And we have water efficiency. Our project connects water directly to the roots instead of all over the place. When it reaches the roots, it helps for the plant growth and it also saves and conserves water. And the traditional method of irrigation involves burning down fossil fuel and producing electricity for the water pump, which can be very harmful and create greenhouse gases. It can trap heat, increase temperature and create a temperature surge. Apart from that, we have operating costs. The initial cost of solar is really high, but the operating cost after that is very low, meaning you don't have to constantly put money in and maintain it. Unlike the traditional method, I mean, even if the initial cost is low, maintaining it after that is very difficult and it's very expensive. And we have plant growth and water conservation, which I already explained. Now I'll explain to you about the statistics. Yogita. Due to the increase in greenhouse gases, over the years, we can see the temperature has increased, which is very bad for our country, as if it goes at this rate, we might suffer a lot. Next. Now we have the CO2 concentration. Due to burning down of fossil fuel, the concentration of our carbon dioxide in Earth has increased. This has caused the temperature to increase on our Earth. Now this is the good part. Solar energy requires sunlight, right? The luminosity of the sun over time has increased. Now we are at 4.56 billion years and it is expected to increase over time. This can benefit benefit our project a lot. And this proves that why solar energy, solar power, solar panels should be introduced in all of the things around our Malaysia. Next. And when I say conserve, this is what I mean. The traditional irrigation system method have created a lot of wastage of water. The wastage of water have increased a lot. Through this method, we can decrease the wastage of water and conserve water throughout Malaysia and all over the earth. And we have Dylan will conclude our whole experiment.
In conclusion, our project shows that we can use In conclusion, our project shows that we can use solar energy, a clean, renewable form of energy, for efficient water irrigation by maximizing the amount of water that's being irrigated while minimizing the amount that's being wasted. This also applies for energy. That'll be all from us. If you have any questions, we'll be happy to answer.
Want us to demonstrate how it works? And as you can see here, we have the blocks that are going to set up. If you have the soil also, the soil will be based on our research. The roots will expand and go to the part where there'll be higher concentration of water. That's how the roots work. Yeah. And if you have any questions, we can answer our questions.
How much would the investment is? Like, what's the investment
For our project, or if you're going to apply this,
application?
we're going to apply this because for normal houses, if you're going to put the solar panel, everything, the whole thing will cost about 25,000 ringgit. But if you're putting this on like a big land like this, because we need a lot of energy, so we're going to times 10 by that or times 20 by that, we're going to put at least 500 or 1 million for just 1 acre or 1.5 acres of land. If we put it on a global level, it's going to cost us few hundred millions to cover the whole land.
Right
now, the only downside is just the huge initial cost.
So it's only a one-time investment.
Right. Okay. Hopefully things will change, but it's a very expensive project.
But once we invest into this, the maintenance cost will be less. So after that, we don't need to spend a lot. So it's just a one-time investment.
What is the traditional cost like for you? Like an estimate?
An estimate we can put at maybe this costs 600,000 like an upfront. So per year we're going to put at maybe that same price, like 600,000 a year to maintain, because we constantly have to buy fossil fuel, burn the fossil fuel, generate electricity, maintain the generator, the parts in the generator, put oil and make sure it runs properly, and all of that. All of that adds up to around that.
In a year's space,
Yeah,
right?
and somehow as year pass on, the price will increase because fossil fuel may become more expensive due to economy and all. So you have any other questions?
In one of your slides, you say luminosity of sunlight increases.
Yeah.
Why?
Yeah, over the years, our luminosity of the sunlight have increased, and it has shown like until at this stage, we are at this stage now, 4.56 billion years. So when we reach here, the sunlight will increase a lot, and we can use this to convert it into energy for our project. This is what I meant. Yeah.
Any other questions? We have water, and we have a hydrofall down there to distribute water.
Who did this? It's very pretty. It's very pretty. Who did this entire thing?
All of us.
So,
But then you either work on the designing part. Me, Dylan, Maxim, and Akib, we worked on the circuits and all of this part. So most of this beautiful decoration
yeah.
and all comes from her, because none of us know how to do all of this. We only know about the circuit part.
I mean, you should not do that. You should also involve
Yeah,
in
but
the
the
creative
circuit part and all, we just do different tasks.
Right. Okay, cool. Thanks, guys.
Thank you, Judge. Any other questions?
Please
do work for us. Please do work for us.
I know that. Okay. Okay, thanks, guys.
Thank you.
Hi, good morning, respected judges. Our group name is PH Power, and today we are here to talk about how natural indicators uses help us to understand their natures. Okay, so ma'am, do you know we can do a real science at home by using the ingredients which is normally available at our house?
We could, but I just don't do it because I don't have time. But yeah, you can have this.
Okay, sure. So today we are going to show you how a simple beetroot can unlock the secrets of chemistry. Okay. So our problem statement is that the chemical which uses in lab are very expensive and they are like not always eco-friendly. So today we are going to see, can a beetroot replace with that harmful chemicals?
Really?
Yeah. Okay. Now Prajit will explain it more further.
Okay, to solve our problem, there are three main objectives. The first objective is to create a indicator by using a beetroot to test the household solutions, and to understand why pH soil is very important for farming. This
So here is the indicator. So this is vinegar, which appears lower than 7. And here is the base, which appears more than 7. So now this is a natural indicator. When I put this inside, you cannot see much difference, right? It's like same color.
Yeah, it's just a distinct red or pinkish color. It doesn't change.
So when I put the same thing inside here, can you see that? Color difference?
Right, yeah. Yeah.
So like these natural indicators help us understand how like the solution is acidic.
Oh wow, I didn't know. Why beetroot is an indicator? Why you guys choose beetroot?
Because we don't have
It's
a
very-
chemical inside that which is called betterlin.
Okay.
And when it like go inside the solution, it will change, it will react with the pigment. The pigment will change the reflection of the light.
Oh.
Yeah.
Oh wow.
So this only works for
Alkaline.
base.
Yeah, it's only work for yeah.
And this is acidic.
Yeah, it's the same. Mostly like indicators like won't change their color in acid, they mostly change in base.
So you can use beetroot to determine whether it is base or alkaline.
Yes, sir. So here's some examples like
How strong alkaline is this?
this one like pH is like between 7 to 8. So here's the same thing like pH is very important in soils also. If the soil is too acidic or base, it will not allow the plants to absorb nutrient efficiently. So as you can see here, inside this soil there's a lot of acid, okay?
Okay.
So the plant cannot absorb the nutrients and it dies. Here the soil is neutral and you can see how well the plant grow because it can absorb the nutrients. Like this here, we put base here, but like some of the plants can grow in base also. So you can see that how like well it grow.
Correct. I'm just wondering what is the molecular composition of beetroot that is able to change the color in an alkaline solution? I'm just curious.
Yeah, just 1 minute. Yeah, you can see that it's contain a natural pigment called betterline. When it meets an acid, the extra hydrogen ions change the chemical shape of the pigment molecule.
If it's base?
If it base, in base, it changes structure differently to look
Right. The structure is different.
Yeah.
Right.
So now, just will explain you more.
So, like he said,
This way, this way.
okay. So, like he said, that when plants do not the plants cannot absorb enough nutrients when the acidity is not balanced, and so for them to be balanced, different plants need different types of soil pH. Here are some examples shown. Also, we have concluded a hypothesis for this experiment that was done. Our hypothesis was very simple. We wanted to know whether adding pH, adding yes, adding BH, adding beetroot juice to different levels of pH to different liquids can change the natural color. This shows that the hypothesis is correct. But only works for the alkaline one. Yeah.
Yeah.
There are also other indicators, not only this.
Like hibiscus flowers.
Hibiscus
is
flowers.
also an indicator. Even this money
Yeah.
plant leaf, when we crush it, this is also an indicator, natural indicator.
Oh.
Yeah.
So if I'm going to crush this leaf and I'm going to put it into a basic solution, it's going to change color to a different one.
Yeah, I
Yes.
think,
Yeah.
Yeah, it will work.
The rares, whereas you can also use turmeric. Right.
Yeah.
Right. But have you guys only tried the beetroot and you guys have not tried other natural compounds?
No, we have tried with the
No,
turmeric. Tried with
What is
turmeric.
your observation?
Observation is like when we put it inside the vinegar, it's not changed much. But like when we put inside the base, it changes into red color. Very
Really?
fast. Yeah.
Oh. Do you have pictures and stuff? I want to see if you guys have.
No, not available.
Anything else apart from turmeric and beetroot that you have tried?
We have some fun facts labeled over there about our topic. So there are 4 fun facts. First is that stomach, over here says stomach acid, which can help in digestion. And as I said, beetroot juice has a natural pigment, which is called
It is called betylite.
betylite, and so it can change naturally. And then when we want to make cakes, like we use baking soda and baking powder, it reacts with the base and substances inside to make it fluffy. Yeah.
Yeah, and acid and base, we don't only use it like scientifically. We use it in cooking also and like in everyday life. And now Hari will explain.
What is our conclusion for today? Like my friend said, beetroot contains a pigment called betalain. When it meets an acid, the extra hydrogen ions change the chemical structure of the pigment's molecule, making it red. In a base, right here, it changes structure differently to make it look purple. So pigment is beetroot. Beetroot is. I'm sorry. I'm very nervous. Beetroot is a very cheap, eco-friendly, and safe way to check the soil's health in order for our plants' growth. Thank you. We will be taking questions. We would like.
So if I have a garden which I have, then I'm gonna buy a beetroot and I'm gonna check by squeezing the beetroot, there's a juice, and then I'm going to put it on the soil, and if it turns purple, so it's a good thing for me.
Yeah.
As in for the plant.
Yes.
People can try like fun experiments doing like use it in their free time.
Alkaline. I mean, alkaline neutral, that's the safest, right?
Yeah,
Also,
no, like every plant have their own nature. Some grow very well in acid, some grow very well in alkaline.
What about the Malaysian tropical, like normal plants?
Yeah, you can
Hi,
see
Mr.
here, durian.
This one is basic. No, this alkaline, sorry.
Yeah, hibiscus, I tell you, right, like this is also Malaysian flower.
Correct.
Which the soil pH level is like between 5 to 6.5, like slightly acidic.
Acidic, yeah.
And you can see we have rice. We have a lot of rice in Malaysia. Durian.
I didn't know that.
Durian, you can see like the pH is like slightly acidic, the pH level of the soil. But for the rice, it's like slightly acidic but near to the nutrient.
Correct.
Yeah.
Then for them, for durian tree to grow, so you need
Yes.
acidic soil.
Yes, correct. Yes,
So then
correct.
only the plant can.
Not the fruit itself is acidic.
Well, durian is acidic.
I think that's my mom.
Yeah.
Oh no, no, that's not
No, the acidity helps the soil to absorb the nutrients. So the plant, so the fruit can grow well.
They stay like balanced, so like you can have better crop yield and better production.
Yes, I do have hibiscus, but I didn't know that it was growing under an acidic solution all this while. It's healthy, but now I know.
Hibiscus also like natural pigment, natural indicator.
Yeah.
You can crush it and you can.
I didn't know the color changed, but I'll try.
Yeah.
Okay, thanks guys.
Okay. Thank you, miss.
should be cleaner, clear to the judge also. Consider me I'm a judge and you prepare yourself.
My name is.
Hey, talk a bit loud.
A bit louder.
Yes, you see, mom.
I think you.
See, my name is Vamika. Say like that. My name is Vamika.
Okay.
My name is Jagan.
My name is Reshma. So today we are testing three types of classic bridge designs, which are beam bridge, arc bridge, and truss bridge.
What is your problem statement actually? Why you are doing this experiment?
We're doing this experiment to prove that this bridge, the truss bridge, is the strongest bridge out of all these three bridges. Because these three bridges are the most common ones.
This is a beam bridge. So the beam bridge is made up of a straight horizontal deck supported by two end of end table. So if you see the weight, yeah, this is 3 kg. The weight causes the beam to bend because it has very low wear strength. Yeah.
To support the weight of the bridge. This bridge, the curved structure transfers the weight to a support, so it's much stronger. As you can see here, it doesn't bend as much as the beam bridge.
And the last one is the arc bridge. The arc bridge is made up of many connected triangles and has a cross section design. So if you put 3 kg on top of the triangle, it is distributed evenly to all the corners. So each corner might have about 0.75 kg of weight. This is not due to the thickness of layers, but is due to the triangles.
So if you see this is total of 13.5 kg.
It can hold more than 13.5 kg, at least up to 20 kg.
But we just couldn't get the weight.
What is the best next shape after triangle? Any idea?
No, because
Because
if you put a square and we put load on top, the square can easily break and snap into halves. So triangle is the best one to use, and it also takes lesser materials than square.
How you justify this triangle is the best? So any formula for this one? Do you have any idea?
No. And this one is mostly used in rural areas like villages. This one and this one are used in cities. The most This one is the bridge from the Penang Bridge. This one is the Victoria Bridge,
Located in Perak, Malaysia.
and this one is the Petronas Bridge.
Yeah.
This is a Penang Bridge which is we go from
Yeah.
here to Penang.
Yeah.
So why they choose when there is more traffic and more people are going this type of structure and this is the best one.
Maybe because that is a bit cheaper to build than this one. Yeah, and that one looks better than this one. And this one is more complex and harder to build, while that one is easy to build.
Okay.
That's all. Please, that's all. That's vote for us.
What nothing I didn't ask much. Thank you. No, vote. You didn't ask for vote. I won.
Of course, uncle.
You
Vote.
should ask, right?
Yeah.
So if you like it, you should ask.
Yeah, please vote. Oh.
The bridge.
I get it. You have to keep it like
You should give more scientific
trust.
answers.
So actually this is based on engineering.
Yeah, it's okay.
No, you should give more scientific answers. Why triangle is the best one?
Mm.
Why the square is not? Why the flat one is not so good?
Yeah.
So where it will be used? You can say that you explain me it's the rural areas
Yeah.
where it will be used. But when you explain this is the best one, why it's best?
Because of like the triangles.
Why triangle is best?
Because
these are the answers
the load is spread evenly to all the
These
corners.
are the answers we will expect.
Yeah.
Okay, you should answer those things. So
Yeah.
you should if you explain further, right? Then they won't ask much of the questions for you when they
We are the Solar Nexus, and today we'll be presenting our project From Sunlight to Motion. Have you ever wondered how satellites in space get electricity? Have you ever wondered how satellites in space get electricity? Do they use giant batteries or do they use giant power cables? The answer is no. They use solar panels to convert light energy from the sun into electricity, which then powers them in space. This allows them to operate in space for many years without fuel. This inspired our project. We investigated how light intensity, meaning how bright light is, affecting the electricity production. Today we'll be demonstrating to you how light energy is converted into electricity, which spins a motor.
Okay, so our hypothesis is when our solar panel faces the sunlight, it produces more electricity and it makes our model rotate. Okay, so our objectives is to investigate how solar panels convert sunlight to electricity. And second one, we're going to demonstrate how the conversion happens of light energy turning into mechanical movement. And third one, we're going to see how solar energy is used in satellites and real life applications.
I will be explaining how does our model work. Our model is based on the principle of energy conversion. Our model has solar panels which contains photovoltaic cells that convert light energy into electrical energy. The electricity will then power a motor which will cause our model to rotate. The amount of electricity generated depends on how much sunlight is hitting the model. Now we'll be demonstrating our project. As you can see, the model rotating very fast. This is because the model is receiving a high amount of light intensity, which then produces high amount of electricity and then powers a motor. Now we'll keep the lights a bit further away. Now, now you can see the rotation has slowly stopped, slowly is moving. This is because the light intensity is quite lower than the one before. Now we'll keep the lights a bit away. The model has stopped. This is because the model is not getting enough sunlight to produce sufficient amount of electricity which powers a motor. That's so we can conclude that more light equals more electricity.
It's moving very slow.
This one?
And you
Yeah.
put it far away,
Yeah,
very
yeah, that's exactly correct. So we can conclude that more light equals more electricity and equals faster rotation. Our observations is that the higher the light intensity, the faster the model rotates. Yeah, while lower light intensity, like a sunset, the model becomes slower. What explain? The same principle from our model is used in many real-life applications, such as in weather satellites, GPS satellite, communication satellite, and satellites from the International Space Station and solar farms all use this method to generate electricity from solar panels.
Okay, ma'am. So I'll be talking about some amazing facts we have gathered today. So did you know that there are over 10,000 active satellites right now orbiting the Earth? Hmm. Ah,
You know
and
that? I know. You know. Okay.
and each of them experience like 16 sunrise and 16 sunsets every single day. And like one orbit takes like 90 minutes. Yeah.
You have something to say? Okay.
Okay, can you please answer this? Okay, guys. So I'm going to show you a visual.
Is when our solar
Visual of what we are trying to talk about. This is our solar satellite. This is the sun, and this is our Earth. So, so
So our objective is the first one, investigate how solar panels convert super sunlight into energy. The second one, we're going to demonstrate how the conversion of light energy turns into a mechanism. The third one,
they are
in
smart.
satellites and real life.
So they build something called rechargeable batteries. So while they are explaining how does the model rechargeable battery? So once they come in here, they use the rechargeable battery. Yeah, they'll rotate, and then when they come back, thank you, ma'am.
They will
Then when they come back,
recharge again.
yeah. So when they come back, they'll stop the rechargeable battery and go to solar panel. Do you understand, ma'am? Thank you so much. Is there any other questions? Right. Would you like to try
Now
our
it's
game?
time for true and false game. One of you will spin the wheel. One of you will spin the wheel and we'll read the statement aloud. And you must guess it's true or false.
Okay. You spin the wheel.
Spin.
Okay, you got real life applications are swimming and eating. Is that true or false? You're correct, ma'am. You
Oh, thank you. You didn't answer
chocolate.
for me, right? You didn't answer the question.
And ma'am, would you like to?
Explain the model.
Oh, okay, ma'am.
So, as Afra said earlier, the solar panel moves from light intensity. So, as you can see, when the light source is very near, it rotates very faster, and as the light source moves back, the rotation stops or slows down because the brightness is very low. Now,
We can conclude that more light equals more electricity and equals faster rotation. Our observations is that the higher the light intensity, the faster the model rotates, while lower light intensity, the slower the model rotates. This same principle is used in weather satellite, GPS satellite, communication satellite, and international space satellite. Now, let me give to my friend to explain some amazing fun facts.
Okay, so did you know that there are over 10,000 active satellites orbiting the Earth right now, and each of them go through around 16 sunrise and sunsets every single day. So, what I'm trying to say is, wait, let me show you. Okay, so this is our satellite. This is our Earth, and this is our Sun. So when the solar panel faces the sun, they charge using the solar panels and rotate. But once they go here, they have something called rechargeable batteries. So while they're at the sun, they charge the batteries. So once they go back, they'll use that to power the system because there's no more sunlight, right? But then once they come back here, they'll stop using the rechargeable batteries and they will start using the solar panel. Right, ma'am? Do you understand? Do you have any other questions? Alright, thank you so much. Would you like to play a game? A game. Spin the wheel. So you can spin the wheel and you have to figure out if it's true or false. Spin the wheel. And the more, is it true or false?
plastic cups. I need you to move them, throw them away, and line up accordingly. Students, all students must proceed to the line. You must start lining up. We will start soon. Students, on the count of 10, everyone back to the line. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, year 3, raise your hands. Year 3, make sure your line is straight. Thank you. Year 4, raise your hands. Straighten your line, please. Thank you very much. Year 5, raise your hand. Straighten your line. Thank you. Year 6, straighten your line. Secondary, lead by example. The teacher should not have to repeat themselves. Straighten your line. Thank you. Ladies and gentlemen, welcome back. We hope you had an enjoyable lunch. Before we continue with the next part of our program, all students are kindly requested to return to the designated seating area. Students, please arrange yourself according to your assigned groups and name list. Please listen carefully to your teachers and make sure you are seated in the correct group. We kindly ask everyone to settle down and prepare for the next part of our program. Thank you for your cooperation. Students, all eyes on me. Reminder, gentle reminder. Students are not allowed to actively use your mobile phones during the program. Please keep inside your pocket. Students are not allowed to go to the washroom without permission of the teacher and do not go to the washroom alone for safety purposes. During the continuation of our program, please do not go to your parents, run to your parents, or run around the hall. Are we ready, students? Ladies and gentlemen, we will now invite our judges to share a few words with us. May we invite our 3 judges to come forward one by one and address our students and give a few words. First, let's give a warm applause and welcome to Miss Joshna Munyandi.
Alright, very good afternoon everyone, and congratulations scientists, you have done a wonderful job today, so I would say congratulations. Alright, as a judge I saw a lot of creative ideas and excellent presentations, so very well done, and I think parents and teachers, you have done an excellent job. And what impressed me the most is all of the students was very confident, very passionate and very creative, so congratulations. If there is one thing I say today is my favorite scientist. Albert Einstein said, keep the questions going on. So when you go back today, keep the question. Ask your parents, why ice float? Why sky is blue? Okay? And parents, good luck with those questions. Okay, keep questioning, keep discovering, and very well done. Thank you.
Thank you so much, Miss Jo. Let's give her another warm round of applause. Next, let's hear a few words or two from Miss Vigneswari Balakrishnan.
Thank you so much guys for inviting me first of all, and students, you guys are so awesome. When I saw you guys just presenting your stuffs, right, I was like mind blown. You guys were so awesome, and always remember, so let me talk about myself first. So I am a student as well, once upon a time, but I fell in love with biology and I'm currently standing in front of you as a genetic counselor. Right? So biology is wow for me, but I've seen that spark in every single one of your eyes when you guys were performing and also demonstrating your stuff. So I want that to be sustainable. I want that spark to be forever. So keep the good work and I wish you all the best and good health as well. Right? Thank you guys.
Last but not least, let us invite Mr. Selvarajan Subramaniam to give his warm words.
Good afternoon, teachers, parents, and students. All right. Today when I was going around all those exhibition booths, was extremely good. You know, the presentation was good. It's not just to say good; it was excellent. The confidence level from the students was very high, and they're able to present whatever they were putting up. So that is what is required. So that the model that you have chosen and the way that you design them and then the way that you present is really, really excellent. Keep it up. Good luck.
Thank you so much to our judges for your valuable words, feedback, encouragement. We would now like to present a token of appreciation to our judges for their time, effort, and valuable contribution to the Able Learners Science Exhibition 2026. May we invite our principal, Ma'am Punita, to present the tokens of appreciation to our judges. Let's give our judges a big round of applause. Let's give a round of applause to Miss Joshna Munyandi. Let's give a round of applause for Miss Vigneshwari Balakrishnan. Last but not least, let's give a big round of applause to Mr. Selvarajan Subramanian. We will now have a special performance prepared for you. Please put your hands together and enjoy a wonderful performance by our talented Year 11 students. Let's give them a warm round of applause.
Hello everyone. I think all of you know who I am. Yeah. Okay. As you all know, this is my final science exhibition in the school. another few more weeks, I'm off to tertiary education. Before that, I have my IGCSE. So I'm going to interact with all of y'all. Okay, there is a surprise experiment preparing, but until then, I'm going to be interacting with some of y'all. So I want to hear how was the experience from some of y'all here. So any volunteers? Jonathan, come on. Come on. Okay, come. Lucky, come. Come on, left. So, Luki, how's your experiment today?
Good.
What did you do?
I did my experiment.
Of course. What was the experiment about? Tell us.
Soluble and insoluble.
Oh, that sounds fun. Do you think you're gonna win?
No.
Why do you think that?
Because of Hania.
You shouldn't. No, this is healthy competition. She is your friend, right? This is healthy competition, okay? Say sorry.
Sorry.
Okay, give it up for Luki. Okay, this time I want someone else on the stage, but special request from me. I want from year 7 onwards. Okay, Miraj. So, what was the experiment about today?
We actually did about natural indicators. Yeah.
For you. Okay. Are you gonna miss me?
Yes.
How much?
A lot.
Why?
Because we have did a lot of things together.
Yeah. What things? What things?
Like talking. Yeah, talking and some other things which I cannot tell here.
Okay. We'll keep it a secret. Okay. Anything you would like to tell everyone?
I will miss Aditya a lot because we spent 2 years together and he's like the best senior ever.
Thank you so much.
And yeah, Chan also.
Okay. Year 9 already. Year 10. Someone faster. Someone from Siddharthan, come up. Anyone else from year 10? Hey, faster lah. Upcoming year 11, faster.
This is the future batch.
Okay, come on, let's clap. Okay, Siddharthan. What was your experiment about today?
Harnessing solar energy for drip irrigation.
I didn't hear anything, but it's fine. Okay. So, are you gonna miss us?
You or everyone?
Okay. Start with me first, lah.
No.
What?
I see you at home every day. I'm not gonna miss you.
Okay. That's valid. Okay. What about the rest?
Yeah, I'm gonna miss them.
Okay. So, and why are you gonna miss the rest?
I had bad experiences with previous seniors, so these are the best seniors I've met so far.
Thank you so much. Thank you so much. Okay. No, it's fine. Okay, so yeah, you can go back. Or do you want to volunteer for our surprise activity? Okay. So we would like a volunteer for surprise activity, but we're not going to tell it what is it. Only you guys are going to see. They're not going to know. Okay, put your hands down first. In a count of 3, yeah? 3, 2, 1. Okay, I'll go to Jonathan first, okay? Let's have Jonathan up. Come on, let's go. Okay guys, the thing is, you guys are gonna see, but he's not gonna know what is up. Okay? That's the whole experiment. Okay, come. Okay. Okay? You have to trust us in this. You don't have to be worried. Nothing is gonna happen. Trust me. You got it, okay? So, do you think it's gonna pop? It is? Oh, okay. This was just a demo of it. Okay, this is without water inside. So now I'm going to show it again. What happens if there isn't water inside? So that didn't have any, nothing was inside. There was a balloon. Now we have balloon with water inside. Before that, do you all think it's gonna pop? It's not gonna pop? Why? Somebody please? Okay, we know last time we did this, but can someone explain me what's the science behind this? Puvin, come on. Give it up, let's go. Okay, Puvin, tell your friends why it's not gonna pop.
The one with the water? Yeah. Because you're literally lighting the balloon under and there's water. It cools down. The material cools down, it doesn't expand. It doesn't expand.
Okay. Do you all think that makes sense? Okay, we at least have to give it up for him. He tried, come on, let's give it up for him. So we are going to light that up now. Jonathan, ready? Okay, in a count of 3, 2, 1. Okay, let's see how long it can last. Count, start counting. 1. Oh my god. So, Jonathan, you escaped lah. Anyone else? Okay, guys, we are going to make it even more interesting now. Instead of students, we are going to call up one of the teachers. Okay. This is, okay, I have made my choices. This is not because of personal vengeance or anything, but she's a great teacher. Let's have Miss Naga on stage, please. Miss Naga, please. Miss Naga is feeling shy, guys. Okay. Earlier, for Jonathan, you all counted up to 15 seconds. For Miss Naga, let's try 30 seconds. Okay, let's try 30 seconds, okay? Okay, in a count of 3. 3, 2, 1, go. Okay, earlier I called one of y'all to explain the science behind this, but my friend Kaushigan here is going to talk about the science behind this, okay? Give it up for him.
Alright, so you guys might have seen when we used the normal balloon, the balloon exploded. This is because when heat was applied, the rubber of the balloon expanded and it melted. So the air trapped inside the balloon came rushing out and it exploded. But for a balloon filled with water, when you heat the bottom of the balloon where there is water, the heat is absorbed by the water. The rubber acts as a transferring medium for heat and it is transferred to the water instead of the balloon, and the rubber doesn't melt. So that's the surface level of why the balloon doesn't explode. That's what you guys need to know.
Hopefully y'all understood that, okay? Thank you so much for, this 5 years was just fantastic. Thank you to every one of y'all, teachers, Miss Punita, thank you everyone. I'm going to miss you all so much. I'll definitely come to see all of y'all next year, okay? See you, bye. Okay, see you, bye-bye.
Thank you, Year 11, for that wonderful scientific performance. Let's give them another big round of applause. We will now begin our award presentation ceremony for the Able Learners Science Exhibition 2026. Today, we celebrate the hard work, creativity, teamwork, and dedication shown by our students. We would like to congratulate all participants for their wonderful efforts. Before we begin the certificate presentation, we would like to inform everyone that the certificates being presented today are mock certificates. The official certificates with the students' printed names will be prepared and given to the students by next Thursday at the latest. Thank you for your understanding. Participation certificates, pre-year 1 and year 2. We will now begin with the presentation of the participation certificates for pre-year 1 and year 2. May we invite Miss Sindhu to present the certificates. Let's give a big round of applause for our pre-year 1, year 1 and year 2 scientists. Congratulations. Thank you. Teachers, please help guide the students off the stage and back to the lines. Thank you. Year 3 and Year 4, Lower Primary. We will now proceed with the participation certificates for Year 3 and Year 4. May we invite Miss Bushra to present the certificates. Students, please come forward when your names are called. Year 3, Water Wonders, Tehani, Dayanandan, Hanya, Harit Dayan, Luki. Year 3, Magic Filter, Viraj, Hamida, Ridvin, Sadru, Safika. Year 3, Secret Scientist, Dwarka, Srihan, Ansh, Haya. Year 4, Solar Detectives, Namasvi, Sajid, Yugam, Janhita. Year 4, Fermentation Malaysian scientists Gabriel, Tusantan, Parnika, Virajit. Year 4 Fungal Stoloniferous Ashwin, Ria, Tanishq, James. Year 4 Water Rangers Garaj, Darius, Caleb, Ibadullah. Year 4 PH Explorers Akshaya, Kritika, Sharu, Rudolph. Congratulations to all of our participants. Let's give them a big round of applause. We will now proceed with the participation certificates for upper primary, year 5 and year 6. May we invite Ms. Diwani to present the certificates. Students, please come forward when your names are called. Year 5, What the Energy? Martin, Roman, Nitya, Arish. Electrical Strikers, Ahmad, Rushlita, Aditri, Hasini, Daniel Sidani. Year 5, Heat Dragon, Nandan, Anika, Narmishan, Ira, Salvi. Now for year 6, Irrigation Trio, Huvin, Sahana, Dharmika. Thirsty Robots, Zarun, Gavinaya, Janika. experimenters Sahasra, Vasavi, Tashwin. Congratulations to our Year 5 and Year 6 scientists. Let's give them a big round of applause. Participation certificates for Year 7, Year 8, Year 9. May we invite Mr. Naveen to present the certificates. Students, please come forward when your names are called. Year 7, Flammable, Ahmad Nawas, Harshini, Sarveen, Jane, Chlorophyll Crew, Varshini, Ashwada, Navya, Raja, Hygienic Crew, Niranjana, Thomas, Jaden, Kavisha, Perseverance, Vaiga, Project, Ahla, Seshadri, now for Year 8, Hydrosol, Jasmita, Laksha, Siddhi, Aaron, Nature's Powerhouse, Satvik, Ashwin, Harsha, Ching Hong, Bridge Architect, Jagan, Vamika, Rashmin, Srisha, Solar Nexus, Haricharan, Project, Jasmita, Danush, Miraj, PH Power, Harshika, Jonathan, Afra, Akshara, Kailash, judges. Let's give them a big round of applause. We will now present with the participation certificates for upper secondary, year 10 and year 11. Students, may we invite Miss Jasmine to present the certificates. Students, please come forward when your names are called. Year 10, Solar Overdrive, Maxim, Siddharthan, Yogita, Dilip, Akib. Hydrogenesis, Tivanka, Cassandra, Matthew, Srijan, Francis. Now for year 11. Green Guardians, Gaushihan, Advika, Jenny, Oswin, Bavinya, Chan. Ladies and gentlemen, the time that we have been waiting for. Winners of the Science Exhibition, Able Learners Science Exhibition 2026. We will now announce the winners for the lower primary category. May we invite Miss Chong Yok Moy, Hillary's grandmother, and Mr. Anath, Ridvin's father, to come forward to present the awards. Give them a big round of applause. Ridvin's father. In third place, congratulations to booth number P3, Secret Scientist. Tavarika, Srihan, Ansh, Haya. In second place, congratulations to booth number P2, Magic Filter. Viraj, Hamida, Ridvin, Saju, Satvika. In first place, congratulations to booth number P4, Solar Detective. Namasvi, Sajid, Yugen, Saijan Hita. Next, we will announce the upper primary winners for Year 5 and Year 6 category. May we invite Miss Aiza Abid, Ahmad Abid's mother, to come forward to present the award. Congratulations to booth number P12, Irrigation Trio, Puvin, Sahana, Dharmika, congratulations, in second place, booth number P13, Thirsty Robots, Zarul, Gavinaya, Dianika, and in first place, congratulations to booth number P10, Electrical Strikers, Ahmad Abi, Rushnita, Hasini, Aditri, Danya Sidani. Let's give them a big round of applause. Congratulations to our young scientists. We will now announce the winners for primary, lower secondary, year 7 to year 9 category. May we invite Miss Praveen, Dayanandan's mother, to come forward to present the award. Miss Praveen. In third place, congratulations to booth number S4, Perseverance, Vaiga, Prajit, Ahla, Seshaji. In second place, booth number S5, Hydrosalt, Jasmita, Laksha, Siti, Aaron Man, and in first place, booth number S3, Hygienic Crew, Niranjana, David Thomas, Kabisha, Congratulations to the winners. Let's give them a big round of applause. Next, we will announce the winners for upper secondary, year 10 and year 11 category. May we invite Mr. Kapil, Tehani's father, to come forward to present the awards. Astrogenesis. Tivanka. Cassandra. Matthew. Srijan. Francis. In second place, booth number S10, Solar Overdrive. Maxim. Siddhartha. Yogita. Dylan. Akib. And in first place, booth number 12, Green Guardian, Darshan, Advika, Jenny, Oswin, Bavinya, and Shah.